Okay, I think we're ready to get started on this Tuesday. Um, so we're going to do kind of two things today. We're going to do a wrap up of um, the course, kind of do a quick review of what we've been doing, talk about how you could make use of this course in the future. What are some takeaways you can maybe be collecting with this course? Um, and then we'll be, and again, we kind of go over, try to put in perspective what we're covering and also how you can keep going in your journey to learn more about AI and machine learning. So that'll be the first part. I hope to do that in about half an hour. We'll see. Sometimes I start going, I go a little longer, but and then the main goal is to give you time to work on your final project. I know some of you are doing that. It's not uncommon for students to be working with data or projects and get, have questions, trying to get this to coordinate with that. So I like to have time in class where if you're having trouble, you can do that sort of stuff. So we'll talk a little bit about the final project and then give you time to work on it in class today for that. So let's just jump into unit 15 here. I'm going to start with the quick review of machine learning and kind of what we tried to cover. This is actually from another presentation. I did this at the beginning of class just to give a quick overview. And I'm going to do the same thing kind of here, kind of to show where we've been with this stuff. So we talked about, the early days, and we really didn't do much with these early systems. We used to do more in this class, but nowadays most of that's we're not looked at. But then we looked at what we call machine learning, which again is a subset of artificial intelligence. And we looked at some of these models, support vector machines, random forest, decision trees, k-nearest neighbor, and a little bit of neural networks there. And again, we worked with these models. Now, these models are actually kind of the bread and butter of data analytics nowadays. And if you're doing any data analysis sort of project, whatever, you're generally doing something like that. A lot of them are supervised learning, where you've got some labeled data and you're just trying to find a line or some algorithm to, organize that data or differentiate that data in some ways or predict some value within that data here. And again, this was just kind of the classic problems, predicting house prices, estimating hospital stays, classifying some numbers, not working with images or anything fancy yet, just working with raw numbers here. We also talked about some of this unsupervised learning here, how we can do some clustering of this. We didn't do too much on clustering. We talked a little bit about k-means clustering and how you can use k-means to do some clustering, and then how to analyze how good these clusters are in some way. And let's see. We talked a little bit about neural networks, and they've been going in and out of favor. Back in the 2000s, neural networks really lost favor, and all these statistical models really took over for a while. I did my PhD back in the 90s with neural networks, and it was kind of popular back then, but by the 2000s, it really lost its popularity here. But then it resurged around, 15 years ago, and we rebranded it deep learning here. We had faster GPUs and huge data sets. And again, kind of the idea a lot of people sometimes say is that once you kind of start deep learning and neural networks, you kind of leave all those other versions behind. I actually still think those versions are used a lot. And if you talk to people who do data analysis, you still use those versions a lot. So, but there's a kind of this meme in machine learning is once you start neural networks nowadays, You just got to leave all the little toy ways of solving analyzed data behind there. We talked about this general model for a neuron where we have some inputs feeding into a node. The inputs each have a weight or an efficiency, and this weight changes over time, and that's what our learning algorithm does, is change this weight. Our nodes does again, weighted sum of all the inputs. We have all of our inputs, we have all of our weights, we create this weighted sum here, and we feed this through some sort of nonlinear function here. There's different sigmoid-like functions, and we generally use now a rectified linear unit here for this. So we have this kind of structure for a neuron. We start layering them together. Here we talked about back propagation, where we could take an output. We put in an input. We calculate all these values in the hidden layer, calculate the values in the output layer, and then we compare it to what we thought the output should be. And then if it was, generally it would be different. And so then we'd figure out how different it was, and then figure out how to change these weights, and then what these values would be and how to change these weights. And this idea of back propagating this error and all the changes of the weights, we could do that throughout this network for this. We talked a little bit about recurrent neural networks, long short-term networks, recurrent or gated recurrent networks, how they're try to analyze sequences of words or time series or stuff like that, and some problems they had with this. I was just listening to a podcast earlier that there are a number of researchers still working on these, especially like long short-term memory things. And one of the problems they had was that they couldn't be parallelized and trained really well. And so there are some new versions of these where they have kind of tried to overcome the problems that were back. The reason why we kind of left them for attention models. There. So this stuff hasn't died. They're still out there. It'll be interesting to see. I keep hearing more and more that our transformer models, our large language models, are going to need more memory like that these might have on them. So we looked at convolutional neural networks, and here we started doing images. Here, remember we did, classifying whale tails or cancer from X-ray images and stuff like that. So ideas, we have these convolutions, we have an image like a 3-layer RBG image, and then we have this convolution value. We looked at it as a 2D thing, but in reality it is a 3D value because we're mapping a 3D source onto another layer here for this. And again, we created these big networks like AlexNet, and we looked at pre-trained models of this with lots of layers set up where we could set up convolutional layers and max pooling layers, and then finally feed this into some feed-forward layers for this. And then we started getting more and more parameters here, big data sets of images, deeper and deeper networks here. We looked at there are ways to try to get back propagation of training work better. Sometimes we did this kind of connection from back in time that skipped over these networks in different ways. So here's our like VGG19, and this is residue layers for that in different ways. So we looked at that, and then again, often what we do is we take someone would train a big long version of this, remember, train it on ImageNet or some huge collection of images, and then we would just cut off the top, the fully connected layers at the top and put our own network on top and just retrain just that top little network, because hopefully this this network would learn some really neat features of our image, and we can just look at those top layer features to do our detection here. Training got more and more time consuming. some point, I think, I don't know, I try to keep training down in this class, but I think I remember I mean, we're getting, I think at some point where training got maybe up to maybe an hour or so, I think, at some point on some of these networks there. In reality, a lot of this training takes days, but again, I don't force you to do that. So we cut these things down. But again, we need faster and faster computers. Just talking to someone on campus who just got a brand new, really fast machine learning computer to do some local training and stuff like that. So I'm interested to see that here. So that was images. Then we talked about sequence to sequence networks, encoders and decoders here, and again, this is where we were going back to these recurrent networks, feeding those in there. We talked about a little bit, and I don't know if we covered reinforcement learning. I had to cut this kind of out of here. It is actually used today, so that's one thing I wish we would have covered a little bit more in this class, is how reinforcement learning works. So if you're interested in something, I would learn a little bit more about that if I were you there, because a lot of the new language models, you learn this. So we talked about tokenizing, how we assign tokens, or basically vectors and numbers to words here. And hopefully we find some meaningful encoding so that we maintain some relationships between the words in this vector space that we've converted the words into. We talk about attention models here, and how we'd feed our encoder into an attention model, and that would tell us which of the input words were important to decipher the output words here. And then that led to self-attention, and then the transformer models, and this attention is all we need. So then at this point, we dropped the recurrent neural networks and just went with feed-forward models with attention here. And so here's our transformer model. And from that, we got all of our large language models. They're trained a lot to predict the next word. And we do some reinforcement learning. So, and again, sizes of these networks have continued to grow here. I remember working with networks with 1,000 nodes, and back then in the 90s, it would take us, I'd run these training things with 1,000 nodes for a whole weekend because the computers were slow back then. And now we're regularly training billions and trillion models with billions of models or of connections, or what we call parameters for this stuff. Right now, we've kind of topped out in some ways. I guess we're seeing a lot of push. We were like ChatGPT 4 is up to over 1 trillion parameters, but there's now a push with some of the competitors and stuff to make smaller models that are just as good. And so not necessarily make really bigger and bigger models, but maybe make more efficient, smaller models. So like DeepSeek was this Chinese company that came out with a smaller model that was trained in a very inexpensively, and it only had 600 billion, which again is bigger than like anything 3 years ago we'd even think about. But today we talk about it as a small model. So that's kind of where we're at. And then we talked a little bit about how we're seeing these large language models in robotics and some other areas. So now, how might you use any of this stuff in this class? So some things you might want to consider doing is, I don't know if you have a portfolio or a collection of stuff you share with future employers or with people when you're on your resume or stuff like that. In computing, it's not uncommon for people to put their GitHub link on the computer or on their resume and have a link to GitHub. So if that's the case, you might want to move right now. Again, our libraries are in, I mean, our notebooks, your notebooks are in Colab here, right? So we have these notebooks in Colab. And again, you could share those with people, but you can also move them to GitHub. So from here, uh, you could copy it to GitHub and have it in GitHub. And so if you're using GitHub to share this information, that's a good way to maybe push some of this stuff. GitHub is set up to display these notebooks pretty well. You can't edit them in GitHub again, but again, they're displayed fairly well for that. So consider moving some of these to GitHub if you want to have some of them out there. Again, you can just share the notebooks and have a link in your resume or something like that. Again, you certainly don't want to share every assignment, but again, if there's one or two of these notebooks that you think illustrates what you've learned, some things you've learned in the class, you can do that. We've completed some of the learning exercise on the badges, and you can post that to LinkedIn here. So you can add those certificates or badges or whatever to LinkedIn here. So that's another thing to consider to do. You can decide if you want to include some of these skills on your resume and how you want to do this. Again, this isn't a Python class, but we've been working a lot with Python. So you certainly indicate that you've been using Python in this class. And we've also been using some libraries, and these are typically listed things like Panda, NumPy, scikit-learn, Keras, TensorFlow. Those are all things that aren't bad to have listed. I think it's kind of helpful sometimes to list some libraries like this if you want to get a job in this area, because a lot of companies now are using some sort of automatic word scanning, first cut of your resume. So just to get you past that first cut. So even if you just say, it wouldn't be bad like to maybe just somewhere in your resume say you took a machine learning class, or you worked on a project, and in that project, I used these libraries. I list some of these libraries out. Or I don't know how else you want to do it. I've seen people just list out, languages or environments or technologies that they're familiar with. So that's another thing to consider for this. So I sent out an email a while back. There's a conference, so you can try to stay involved in data analytics here. So Mini Analytics has a data tech conference coming up in June. It sells out, and I just noticed it is sold out already. What? Oh, May. Yes. Sorry. Yes, it's in May. I should change that. So you can join the waiting list, although and see if that goes there. I'm going down to it. I will be sending out an email probably later on this week just to check if anyone else is going to it and needs a ride down to it there or not. So I can decide that. So that's a good thing. Now, if you didn't sign up to go to that, another thing you can do is, and then this kind of ties into down here, where we're talking about like follow certain people on social media. One thing that's interesting to do is you can look at who's speaking in Minnesota. And this is just a local Minnesota conference. So these are the best, the people who are doing data analytics at these different companies in town here. And so you can often look these people up and follow them on LinkedIn, or connect with them on LinkedIn, see if they have a social media thing, something like that, and get connected with them. I find it's very useful to do that. Even if you're not at the conference, you can still follow. Say, I see you're speaking at this at this conference, and I wish I could go, or something, or just say that because they're at the conference, they will get dozens of people connecting to them and stuff. I mean, that's one of the reasons why they're doing this conference too, is to connect with people too. So they will expect connection requests from speaking at a conference like this here. So you can look these people up, see who's speaking, especially, companies that you find interesting or stuff like that. Just connect up with these people who are doing different things. And so that's why I also linked up, I left the link to Data Tech 2024 here, because again, they are listing the speakers there that you can also connect up with and see. So consider that. Oh, also, you might want to just join the Mini Analytics mailing list here. If I just go to, join Mini Analytics, you can just type in your name and email address and ask to get an email every time. And then you'll get a monthly email of upcoming events and stuff like that here. Again, you'll get their newsletter for this. It's surprising. They don't have, in their newsletter, they actually have, I wonder if they show the newsletter here. No. They actually have a number of events. So they have a number of user groups, like a Python or data analytics user group or things like that down in the Twin Cities that meet once a month or stuff like that. So there's often 2 or 3 activities every month going on that they'll send out in their newsletter and other things like that. So it's a nice way to keep connected. And again, it's right here in Minnesota for that. So again, that's one way to stay involved. Another way is to do a Kaggle competition. So again, there's these competitions here. And you can look at what the newest competition. Sometimes these are just, it's fun to either try to do them yourself or to get a small team together and work on one of these stuff. I'm working with another student. We're probably doing one of these over the summer related to cancer research for that. So again, it's nice environment to just keep active in that. And then you're going to be sad this summer. In a couple months, you're going to, I really miss not learning more about machine learning. You're going to be sad. And so to not be so sad, this is what you can do. So there are some nice classes here. Again, we've done some of these, Microsoft Learn, Kaggle Learn, AWS, Google machine learning classes. So all of these are out here. You can do some of these. And again, we've done some of these, but again, there are more that you can do and always new ones here. I like podcasts there. So here are some podcasts and some YouTube channels that you can follow. So some of these are YouTube and some of them are podcast things that you can follow here. I also said, if I don't know what social media you use, but I suggest you kind of follow some AI machine learning people on social media, figure out how to do that. Usually social media is pretty good where if you can grab a couple contents, and watch a couple videos, search for a couple videos, a couple terms, it will then, pull you over and show you more. And if you can, again, interact or, follow some of those people, it will suggest even more people. So you don't necessarily have to do that deep of a search here. If you just search for a couple things, a couple terms, search for your favorite humanoid robot or something like that on there. So, a lot of you are already data analytics minors, but remember we do have a data analytics minor here that you can take. You take CIS principles, our database modeling class, machine learning, which you're already in. You have to take data storytelling, our visualization class there, and then a stats class and an analysis, a data kind of analysis class here. So consider doing the minor if you're not already. Oh yeah, yeah. Well, I was going to talk about the masters. So you can get a master's in applied data analytics here and do that yeah, after you graduate with your undergrad here for that. And there's a new, oh, I don't know if I have the new AI certificate here. Yeah, but I don't think I have it linked in here. So yeah, there's a new certificate in applied artificial intelligence, which leads into our masters in applied data analytics. So these are the first couple courses in that. So you can take some of these courses, applied application machine learning, applied text analytics, AI governance and strategy, and then intelligence agents here. So I teach this course, and it's very much like this course. This is an advanced version of this course. So you would like that if you'd like this. So, okay, so that's some things you can do to continue to learn. Okay, how are we doing? I'm going to try to wrap up pretty soon to give you time to work on this final project. Okay, couple things. Complete the course evaluation if you can. And then for the project, remember, you want to submit your final paper. Right now, that's due on Sunday. I would do a little early here. Let me know if, again, if you have a lot of papers, like if you have another professor who also has his paper due on Sunday and you're thinking, I don't want to do both papers by Sunday. Can I do one on Wednesday or something like that? Talk to me and we can work out this stuff. Again, it's always hard for, again, all of us faculty are doing the same thing. We're just going, well, we don't all want the papers due at the same day there. So we pick either early or late or in between. And so I'm doing early in two of my classes. But if everyone else, if your other classes are doing early too, let me know and we can extend one of these. But unless you ask for an extension, it's due on Sunday night here. So, and then your presentation, you should sign up for a time for a presentation. So let's go down here. All on-campus students have to give a presentation in person. Here you have choices. So Thursday, we're gonna do presentations and then have time to work on your final paper here. At this point, your paper's not due, so your presentation, you're gonna be showing preliminary results. So you don't have to have your final paper done to do your presentation there. You know, you can still be editing your final paper. Hopefully you have some preliminary results to show us there. So you can put that on Monday. We have a Zoom session Sunday night. We have an exam time on Thursday, May 8th there. So since we don't have an exam, I know you have that time free, so you can do it then. And then there's other Zoom time here. So, no, don't show up for the exam time if you're not going to present there. So I'm kind of hoping no one signs up for the exam time because then I don't have to come in early either then. But if you want to, that's fine. I'll probably be on campus anyway on that Thursday here. Yeah, so okay. So those are your options. Pick one of those options and put your X in one of those spots. Online students have the option, you can sign up for one of these Zoom sessions and do that, or you can do the video recording. And again, that's only available for online students. So people people that are on Zoom like now, even though you're not here, you're on, I mean, like Alex, you are still an on-campus student, even though you might be online technically, right here. So, but you are an on-campus student, so you still have to sign up for our presentation. So only officially online students can choose the video option here. And then you have to write your paper here. I just note, I put out a little guide to help you how you might, if you are using AI, and I would hope you're using AI at some point, some ways to help you with your presentation. So, and your research. So our goal here is you should be you're learning something through this paper, and you're writing about a topic that's interesting. You're doing this research there. So certainly in your preliminary investigations and that sort of stuff, AI is a good tool. Even when you're researching, when you're trying to find sources, often even might use like Google Scholar or something, or I'll use AI to find some sources and verify them and look them up in Google Scholar and then start reading them. And then I'll get stuck on different areas of these sources and I'll have AI explain them to you. If you go on to grad school, it's a common activity in grad school are these sessions where, and often they have it like once a week, where they'll have grad students present papers, not their own papers. What you'll be given is you'll be given a paper and say, read this paper, figure out what it's actually saying and present it, because these papers are quite hard to understand often. These academic journal papers, they're hard to understand. And so you'll read the paper, you'll try to understand it, and then you'll present the results. Often it's also common for teams of grad students to get together and try to understand a paper and what a paper is saying. No, you're not in grad school and you're not doing that, but you can kind of use AI as your partner in research, I think, where if you're reading through a paper and you get to sections like, what in the world is this? What does this graph mean? What does this mean? You can ask AI and work with AI as a partner. So I'm often I don't like my personal stuff. I don't like to give AI the whole paper and just say, give me a summary of it. I want to read the paper. Okay, I never read all the paper in all these 10 pages. I like to read sections of the paper to get the idea of it and follow it. And then when I get to certain sections, I'll ask AI to summarize, like, what in the world are they talking about here for this on this page or stuff like that. So as far as writing goes, I think you should be writing the first draft yourself and then editing it. Now I was just talking to my other class. Oh, we're all kind of figuring out how to use AI here. And I mean, if you're doing some non-important writing, you can just have AI write it for you. I mean, I will write, there's lots of stuff I have to write, email or this or that, where, I just need to do the minutes for this thing or something. I have notes and have AI write this. So I'll have AI just write stuff for me at times, but there are also more critical things that I'll have AI just assist me at. And I think this is, again, one of these areas where you don't want to have AI just writing this for you. You're not going to learn as much. So you want to try to make sure you have your own voice and tone in this paper. So you want to probably write it yourself and then ask AI for ideas. So again, we have some example prompts down here, that I would suggest, like, what is the main argument or thesis of the paper? Is it clearly stated in the introduction? Is it clearly restated in the conclusion? Does every paragraph contribute and support the development of that argument? Point out sentences and sections that could be clarified, expanded, or restructured, and stuff like that. So you can, I think once you get your paper done, this sort of stuff, I'm horrible at spelling and grammar and that sort of stuff. And Grammarly helps a fair amount, but I also like to have AI go through and help with some of my awkward writing stuff. I don't like it to rewrite it. I like it to suggest things I use this with code too. There's sometimes where I have it rewrite and just generate code for me to use, but often I would rather it just make suggestions like, oh, look at your code, this line, this doesn't look quite right, or you might want to change this here. And then I can go in and change it because I learn more that way than having it just generate a result for this. Okay. Questions on the final project? Remember the whole final project thing is here. Questions on that? Okay. Yep.
I present on Monday. I mean, on this coming Thursday.
Yes.
Are there any other class times after that?
No. Right. So, yeah, you have to just be at one of the presentation times there. So, and hopefully you want the one you're going to present. Again, you're welcome to go to the other ones and see them, but you don't. Am I giving extra credit in this class for the show? Yeah, so the other thing you might want to consider is the CIS showcase is coming up, so you can get extra points to just share your work at the showcase on Monday at 4. That's I mean, I think so. The CIS showcase or the technology showcase every semester, people are showing their different projects and stuff like that at the showcase. We'll have pizza and stuff like that. So I think it's a fun activity. So even if you're not presenting, you might want to just go to that. So see all the Raspberry Pi projects from the architecture class and stuff like that. So all right. Any other questions? Okay, I want to let you then work on the final project now. If you have questions, I kind of expect students to get stuck on their final project and ask me for help. So I expect, I budget time in this. So don't feel like, oh, I should bother Tom. I expect every student to ask me 1 or 2 questions on the final project during the next week there. I kind of in my mind allocate, a half an hour to an hour per student is my estimate on this. So, you have that time in my schedule already. You should, if you need help with something, feel free to contact me. So, okay. All right. Let's stop sharing. Pause the recording.